day. We have to see this study of D block elements, part second. I am Dr. S.P. Deshmukh, Department of Chemistry, Dayanand College of Arts and Science, Solapur. So here we have to see what are the general characteristics of D block elements, in which we have to see in the color in previous lecture. Now we have to see what's its magnetic property. So when we see the magnetic property, we have to aware about what are the different types of magnetism. There is having diamagnetism as well as a paramagnetism. So when there is a having paired electron, it is having diamagnetism. Unpaired electron leads to paramagnetism. But there is an arrangement of the electron with respect to applied magnetic field. It is an anti-parallel or parallel. Also, when we have to apply magnetic field, they have to weakly repelled or attracted. So in case of diamagnetic, it is a weakly repelled, while paramagnetic it is attracted, and that which we have to see in this figure also. So magnetic property, in which also paramagnetism, diamagnetism, ferromagnetism, antiferromagnetism. But in case of ferromagnetic, higher attraction and leads to permanent magnetic property. For the some example like to be iron, cobalt and nickel. So why we have to see the magnetic property and which magnetic moment. So ions with having different oxidation states show different number of unpaired electrons, which leads to magnetic moment. So calculated magnetic moment and observed magnetic moment. So here we have to see whenever there is having no unpaired electron, there is a no magnetic moment, but having the unpaired electron which leads to there is a observed and calculated magnetic moment. So this is the one property. Another property is a catalytic property. So this transition elements showing the catalytic property. Why? The catalyst, what it mean by catalyst? Catalyst is a species which can enhance the rate of reaction and remain as it is at the end of reaction. So which does not take part in the reaction actually, but it promotes that reaction. So catalyst undergo its physical changes, but it doesn't show any chemical changes. It required in very small in quantity. It activity changes rate of the reaction, rate of reaction, and this activity is a maximum at an optimum temperature. It also provides the new mechanical pathway for the reaction, and it does not change the energy and extent of reaction. So here right hand side figure which tells us the different how the catalyst would be prepared, what are its different factors like to be binder, peptide, zeolite, so like to be, and they have to combine, and then we have to use the catalyst for the such type of different applications. Then the next one, that is a tendency to form the complexes. So how there is a complex would be formed. So what are the factors mainly responsible? Why complex playing major role? So complex would form due to presence of very small size of central metal atom. Second one is having high effective nuclear charge, high positive charge density. There is also having vacant d orbital, which is ability to gain electron from the ligand. This ability to form the complex as well as pi bond formation. They are generally weak electropositive in character. They are also having redox. It means there is oxidation and reduction would be takes place. They are stable due to pi bonding, and generally zero oxidation state complex are more stable. And these are the some reasons why they have to show the formation of complex, and that after formation of complex which leads to different property with respect to metal and ligand. Then when we see the comparison, these are the different characteristics of transition elements, basically 3D block elements. Then we compare first transition series with respect to second and third. When we have to compare it, at that time with respect to electronic configuration, the n-1 shell for 3D, 4D and 5D. Second one, there is a sequential addition of electron from D1 to D10 case. Generally, there is having more stability for the D0 case, D5 case and D10 case. There is having anomalous behavior for chromium and copper. Also some other elements also. There is also possibility for the nuclear electron interaction and electron-electron interaction. So that would be having leads with respect to electronic configuration. When we have to compare with respect to reactivity, the transition metals are generally smaller in size. They are high effective nuclear charge and ionization energy. They are better in the sense higher heat of sublimation and low heat of hydration of ions. Low reactivity. Noble metals are generally non-reactive. And reactivity decreases from first to third transition series. First is more reactive due to smaller size and high polarizing power. So 3D transition elements are more reactive and therefore maximum elements in the nature we found with respect to 3D means abundant in nature. And the periodic reactivity decreases from copper, gold, silver, decreases and hence there is having some stable like to be copper, silver, gold, platinum are more stable rather than other elements. So with respect to reactivity, we have to compare this one. If we compare with respect to stability, +2 and +3 are very common oxidation state for the first series than that of a second and third. Cobalt +2 is more stable than the rhodium +2 and iridium +2. In this case of complex, cobalt show the complex while rhodium +3, iridium +3, they have not ability to form the complexes. All series middle elements are generally higher oxidation state, in which manganese 7 oxidation, technetium, radium, osmium, molybdenum, they are higher oxidation state. And higher oxidation state are more stable in second and third stage. Reactivity decreases from first to third series. How? It decreases reactivity. Why? Because first series are more reactive due to small size and high polarizing power. And similarly, there is having period reactivity decreases and which leads to some stable elements copper, silver, gold and platinum. When we see the magnetic behavior, almost all show the paramagnetic behavior due to a presence of unpaired electron. So first transition series magnetic calculated using spin only formula, that is mu of square root of n into n plus 2. Then small atomic size, more nuclear force, effective nuclear electrical field. So these are the some comparison of first transition series with respect to second and third transition series. Thank you so much.